All right, y'all. So the way I do these help sessions is you have questions, so I'll just open up first. If y'all have questions, if you're not able to attend, you can always send your questions to me beforehand, and then I'll address those, at the very beginning of the help session. We usually go for 40 minutes or so, but I'll stay for the full hour. I'll stay for longer than that if you need. Although if I stay too much longer, I'll get hungry, and then, I don't know, angry maybe. But what are your questions? Y'all understand, first of all, what the quiz is going to be like? That the quiz is really going to look a lot like the first couple pages of these exams. There will be, I think I have one estimation, 2 trig questions, one the angle, one of the sides that you have to calculate. I have a couple of dimensional analysis questions. I have I think I have 2 sig fig questions. I have 1 standard question, and then I forget what the last one is. What am I missing? Unit conversion, and then 1 or 2 unit conversion questions. So it'll look a lot like the first 10 questions, 10 or 11 or 12 questions on each of the exams. You'll come in at the end of class, last 20 minutes, I'll give you the bubble form, I'll give you the quiz, you fill out the bubble form while I'm handing out the quiz, and then you'll have 20 minutes. When you're done, you can get up and leave. Okay? Have any thought, ideas, or questions about just sort of how we're going to run the quiz?
Yeah.
Yeah, Ashton? So you do not need to know any conversion from like the British system to the metric system, but you do need to know the metric prefixes. So you're not given anything about the metric prefixes. You need to know all those metric prefixes, but the big ones that I'm going to ask you are milli, centi, and kilo. I don't think I've ever asked anything other than milli, centi, or kilo on any of the past exams. Later, you'll need some of those other ones, the giga, the mega, the nano, the micro, but not right now, okay? Kilo, milli, centi. That's 10 to the third. Milli is 10 to the minus 3, and centi is 10 to the minus 2 centimeter. Are there questions about that? Yeah, no equation sheet otherwise, but if you need conversions for British system, I'll give that to you on the quiz. All right, questions that you want me to work through, or maybe types of questions that you're just having difficulty with. Yeah, Ashton, shoot.
I think it was 3.
On this first exam, fall 22?
Yeah.
Okay, yeah, so you'll have 2 dimensional analysis questions. This is what I was going to work. Did you have a specific question, or you want me to just work through it?
Number 2 on number 3. The second.
Okay, yeah, so first of all, number 2, recognize that this thing right here, that just means initial. So I don't need to worry about any subscripts that are in any of the equations. I can just get rid of that. And likewise, I also don't worry about any constants like that. We just assume that those don't impact the units at all. The 0 just gives initial conditions, that's what that means, and the half is just something that comes about when you integrate that equation. It's just a coefficient from the integration. Then I put in the units for each. X is in units of meters. That's equal to x, which is in units of meters, plus meters per second. That's v times seconds. The seconds cancel. So still, I'm okay. I have meters, 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 plus a, which is meters per second squared, times second squared. Those cancel, and I'm left with meters on every one. This is actually one of our kinematics equations, so we'll see that in Chapter 2. But right now, you need to be able to do the dimensional analysis on each of those. One of these that's more difficult is number 3, because, hey, okay, that's fine. Number 3, because I have velocity, which has meters per second in the denominator. Can we look at that one? Yeah, so I first do x over t, that's easy. Meters per second equals, acceleration is meters per second squared times seconds. So the seconds in the numerator cancels with one of those in the denominator. I just get rid of one of those. So far I'm okay. I have the same units in each of the terms. Plus x, which is meters, and then v is meters over seconds. But if I write this in a different way, meters times seconds over meters, I would write it like that. because I take that meters per second in the denominator and I flip it, bringing it up into the numerator. And these m's will cancel out, just leaving me with seconds. So is 3 dimensionally correct? No, not dimensionally correct. So that one is not an answer. So the answer can't be this or this. It has to be one of the others. All right? You want to do the first one too? Let's just take a look at it. It's not easy either. I'll do it in red so you can tell the difference. So I have meters per second. And then I like to separate the variables out, especially when I'm dealing with fractions. So I have meters per second times 1 over seconds. That's going to be meters per second squared equals meters per second squared. So far, I'm good. Get rid of the half plus meters per second, that's V, but it's squared. So I have to square both the meters and the seconds. And then I have 1 over x, which is 1 over meters. So that gets rid of a meters there and there. So now I have meters per second squared for every term. So both 1 and 2 are correct. So D is the right answer. Okay? Can we do number 4 as well? We've done one of these in, oh no, not number 4. Let's go to, let's do number 4 on exam 1, fall 21. So this is a question where I'm asking you for the units of R. So there'll just be some variable in the equation, and I'll ask you the units. I'm pretty sure that there's a question like this. I commonly ask these questions. So on this one, what I would do is well, what is my first step? What do I do first here? Get R by itself, right? So I'm going to solve this for R. In order to do that, I divide both sides by T. That gets rid of that T. And so I get R is equal to A over TV. That is going to be meters per second squared. Now I'm just replacing each variable with its units. 1 over seconds. And then 1 over meters per second, which is going to be seconds over meters. So that's this right here, this term, is the 1 over V from that expression. This cancels with that cancels with that, and I'm left with 1 over second squared. So D is the right answer. Just want to remind you again that the questions that you'll see tomorrow will be exactly the same as these questions. They're not going to be changed, they're not going to be different, they're going to be exactly the same. Now, the order of the answers will be different because I scrambled those, but you will see these exact questions from past exams. I don't tend to dig too far back into past exams, so I would focus on the last, 7 years or so, what I put on that sheet. Okay? So there aren't that many questions for you to study through. I mean, that's quite a lot, actually. If you go to the past 7 years, that's 70 questions, roughly, for you to be practicing. But most of those are very similar. So if you get the hang of them after a couple of times, then you should be just fine for the quiz. Other particular questions that y'all want to look at. Yeah, sig fig. You'll have 2 questions on sig figs. You'll have a question like this, where you have order of operations, we have to follow the order of operations, and then you have another question just identifying how many sig figs there are in a number. Okay, if you look back at the past exams, you'll find examples of both of those. This is a great one where you're doing the sig figs for this expression. So first, I do what's in parentheses, so that's 3.25 plus 45 divided by 2.4 minus 1. Well, that would be 1.4, but I keep the lowest number of decimal places. So I would just record what there? What's that? That's right, I just put 1. So I'd have 3.25 plus 45 divided by 1. And then I do multiplication and division. So I'm going to do this part. That would be 45, except I'm going to keep the lowest number of sig figs. So it's not going to be 45, it's going to be 50. Right, so it's going to be 3.25 plus 50. And now I would get 53.25, but I keep the lowest number of, what is it, sig figs or decimal places? Decimal places, right. I have 2 decimal places and no decimal places, so I keep no decimal places. So that would just be 53, but I'm asking for the number of sig figs, so C is the right answer. Okay? You'll have a similar question to that. You might have that question, in fact. where you just follow the order of operations. Parentheses, then multiplication and division, and then addition or subtraction. And in each case, you apply this rule for sig figs properly, where you're keeping the right number. I think y'all know how to do this. Right? Y'all know how to do sig figs? You had it in chemistry last year. You have it this year. You had it in high school. You're probably old hand at this. You're going to have, I think, one question about standards. Just know your standards. And not only that, but be careful, because sometimes the standards get all mixed up. So like I might say that the standard for the meter is based on the distance that a cesium atom oscillates, right? So that's actually mixing up the standard for the meter with the standard for the what? The second, right? So just be careful with that. Also, be careful in knowing what is the current standard. So I might say that the standard for the second is the fraction of the solar day. It used to be that, but it's not anymore. Now it's the frequency of the cesium atom, or the period of the cesium atom. I'll use those interchangeably, frequency and period. All right, you're going to have some trig questions. You'll have two trig questions, okay? One, I'm going to give you a picture of a triangle, or I might give you a coordinate system with a point in space, in which case you'll need to draw the triangle and know what the sides are, and then calculate a side and calculate an angle. So in this case right here, you're calculating the, what are you doing? The angle. So remember our mnemonic, SOHCAHTOA? Here I know there's the angle, I know the opposite side, I know the adjacent side. So what can I use to find the angle? The tangent. I would say tan of theta is equal to √3/1, and then theta would be equal to the inverse tan of √3/1. I think that's 60, right? Isn't that 60? All right, so that's 60 degrees. That's a special triangle. And then also, you want to know be able to find the hypotenuse. That's a squared plus b squared equals c squared. So it's going to be √3 squared plus 1 squared is equal to r squared. That's 3 plus 1, which is 4. So that means that r is the square root of 4, which is equal to 2. So E is the right answer. Okay? So you'll have two questions like that, where I give you a triangle, find the side, and not necessarily the hypotenuse, it could be one of the legs, and find the angle. Know your trig functions, know the Pythagorean theorem. Then also I'm going to give you a question similar to number 9. That is a unit conversion problem where you have to deal with power, like units to a power, to a squared or a cubed, like this one, where you're finding the volume of a soccer ball. I give you the radius is 4 inches. And this, for example, is a case where you need to know the conversion for British units, but I give it to you. So you would convert the 4 inches into meters and then calculate the volume of the ball in cubic centimeters. So a couple different ways you could do this. Let's convert the radius to centimeters. So I have 4 inches. I have 12 inches to 1 foot. So that gets rid of the inches and leaves me with feet. And then I have 1 meter is 3.28 feet. I'm putting the 3.28 so that the feet cancel with that and it leaves me with 1 meter. But then I want it in centimeters. So I say 1 meter is 100 centimeters. Or you could say 1 centimeter is 10 to the minus 2 meters. Either one of those would be correct, but you do have them in that order there. And then you solve for that. 400 divided by 12 times 3.28. I get 10 centimeters. And then if I want to know the volume, I actually give you the volume of a sphere right there. That's going to be 4/3 times pi times 10 cubed. So it's a 10 to the 100,000, 3,000, 4,000? Yeah, 4,000 cubic centimeters. Okay. You probably could have discarded A, that you know that a soccer ball isn't 30,000 cubic centimeters. Well, maybe you know that, maybe you don't. Probably just best to calculate this. All right. And then number 10 here would be an example of knowing your metric system, which I'm pretty sure there is a question there, just asking you to do a metric conversion. Well, how many millimeters are in a meter? You just have to know what milli means in order to answer that. What, huh? Yeah, what does milli mean? What is the definition of milli? 10 to the what? -3. 10 to the -3 is 1 over 1,000. So there are 1,000 millimeters in a meter. Or if you forget, remember in a meter there are 100 centimeters, and in each centimeter there are 10 millimeters. So 100 times 10, that's 1,000. So there are 1,000 millimeters in a meter. That's going to be the quiz. Dimensional analysis is probably the hardest part that you'll face for most of you, that students just tend to struggle with that the most. So we'll do a couple more of those. Estimations. You're going to have estimations. I would just look back and review all the estimations for the past 7 years. There's usually only 1 or maybe 2 for each one. And just think about those. Think about what is the size of a centimeter or a kilogram or a meter or whatever, and just sort of have those on your mind. Don't try to memorize them, but just sort of think them through, okay? Any other particular questions? Okay, to do some more dimensional analysis? Yeah, Mia?
I don't know if we're going to go back this one, but on 2017, number 8.
Uh, 2017. What was that? Yeah, that's a fair. I could go back to 2017. That was if it was on the key. Let's say that if it's on the key, which 2017 is. I think it actually goes back to 2014. Is that right? Yeah. Pretty sure I don't have it from 2014. Number 8. Is that what you said? Okay, yeah. So this is a fine question. This is a little bit different from the triangle question. You work it out the same, but the only difference is that I want to know the angle from this line over to here. So it's a little bit more difficult than the triangle question. The first thing you have to do is to figure out what is this angle right here. Let's just identify this triangle. It has a side of 5 units and 2 units. And so let's call this angle phi. The tangent of phi is going to be opposite over adjacent, or 2 over 5. So that means that phi, that angle phi, is going to be the inverse tangent of 2 over 5. So I get 22 degrees. And then, in order to find the angle that I really want, which is the angle measured from the x-axis, then I have to add 22 degrees to what value? 180, right? So 180 plus 22, keeping proper sig figs, would be 200 degrees. Be careful with your calculator. I've said this in class. Some of your calculators are savvy enough that if you put in the inverse tan of -2 over -5, then it will give you 200 degrees or 202 degrees or whatever. But most of your calculators are not savvy enough. In fact, you probably wouldn't even think to do the inverse tan of -2 over -5. But just be aware with your calculator, always draw a picture. I mean, in this case, you have the figure here. But your calculator probably isn't smart enough to get the angle right. But you really need to draw a picture and then figure out which quadrant you're in, and then determine which angle is appropriate for that quadrant. In fact, for this one, I could have gotten rid of a number of answers, since I know it's in the 3rd quadrant, and the 3rd quadrant goes from 180 to 270. I could have gotten rid of these 3, and I could have even gotten rid of option A, because watch this. Let me erase all this. Because further, I know that this quadrant is split with a bisecting line, a 45-degree line, that goes from 180 to 225. and then from 225 to 270. Did y'all see what I just did there? And so since I see in the figure already that that line is above that bisecting line, then I know it has to be between 180 and 225. And so the only answer there is 200. Usually, especially on problems like that, usually there's an easy way to answer the question. And if you know your unit circle, then there's probably an easy way out. Any of my questions will have an easy way out. So be looking for those as you're practicing. Getting a feel for sort of how I write questions will really help you on the exam. And now's a good time to do that. All right. What else, y'all? What other questions can we look at? So here, by the way, you're supposed to find the length of the line. It's just going to be the square root of 5 squared plus 2 squared to find the length of that line, the Pythagorean theorem. Most of your questions will come from younger exams. I think we did these in class. You want to do another dimensional analysis? Is that okay? Yeah, all right. Yeah. I think that is a yes. Okay, so here, let's do the xt. That's meters times seconds equals to meters squared times seconds over meters. Do you see what I did there? I flipped that speed, that velocity. This cancels with that, and I get meters seconds. So far I'm okay. I don't worry about the half. Plus meters per second squared, that's acceleration, seconds cubed. This cancels with 2 of these, and that leaves me with meters second. So far we're okay. That gives me this is not an option, and that's not an option. All right, now the second one, remember the naught, I don't really worry about that. Meters per second equals meters per second plus, what is A? Meters what? Meters second squared. All right, that's acceleration times seconds. That cancels with one of those. That one's okay. So that gets rid of that and that. So E must be the answer. I could do the third one, but I don't need to, right? Because I've already eliminated all those answers for E. Let's say we want to do it. Let's just go and do it. If we have extra time, probably will. Then we'll have meters per second times T, which is seconds. Seconds cancel. X is meters plus meters per second squared times seconds squared. That cancels. And so I'm left with meters on all 3 of those. So the third one is correct as well. But again, I didn't have to do that because I'd already eliminated all the answers. Very good practice for you to do that. For y'all that are going on to take standardized tests, which many of you will, the GRE, the MCAT, various other things that you're, what's the OT? Or none of y'all are OT, are you? No OTs? No. PT? Y'all take GRE. Okay, I think you do. All right. Remember, don't worry about the free response. But there's another one of those. Forget who asked. Kaylee, you asked that one? Kaylee, right? Kaylee? Okay, somebody asked that. Was that you, Mia? Yeah, you asked that one. So another one similar to that. On this one right here? Yeah, so here, this is a similar dimensional analysis. It's sort of like where we were solving for R, but there's no R. I'm just asking you for there's free gum for everybody. Well, I'm sorry, what are the units of this expression? And so I have A, which is meters per second squared. X is meters. V is meters per second, but because it's in the denominator, I'm going to do S over M. And then T is seconds, but it's in the denominator, so I'll do 1 over seconds. So now that I have all this set up, I can make some cancellations there, there, and there, and I'm left with meters per second squared. These are difficult for y'all because you haven't done algebra in a while. Or hopefully you have. If you were in trig, you probably did quite a bit of algebra. Some of y'all might have tested out of trig. That's probably why these are difficult for you. But it's good practice as we move into chapter 2 because we're going to use quite a bit more algebra as we move into those other chapters. All right. Other questions, y'all? Y'all feel comfortable with this quiz? Doing all right? It's usually a pretty high-scoring quiz, but it's also the easiest quiz. So I really want a good performance on this. That way, if you slip up a little bit on the second, third, or fourth quiz, then you have this to bank on, right, to pull your grade up. So do really well on this quiz. No pressure, but you probably don't have any exams yet. Do you have exams yet? No other faculty giving you work to do, right? No other work in other classes. That was a joke. You seriously don't work in other classes? Oh, that's lame. I'm sorry. They should be giving you work to do. Huh?
2 weeks in.
I know. We're like a fifth of the way done with the semester. Almost. Well, a seventh of the way done with the semester. Okay, well, that's all I have. I think we've worked through all the major questions. But if you need extra help, come see me. I'll be around for another 20 or 30 minutes. I can stay if you need extra help. Unless there are other questions. Other questions? All right. Don't leave. Let me make sure that I got your name as you're walking out the door. Gosh, 26 minutes.